All right, so this one's number 24 from page 269. All right, we're supposed to write a two-column proof proving that triangle YXZ is congruent to triangle WZX. Now, if you'll recall, we started off with the definition of congruent triangles, which says that two triangles are congruent if and only if all 6 pairs of corresponding parts are congruent. In other words, all 3 pairs of corresponding angles are congruent, all 3 pairs of corresponding sides are congruent. That's a total of 6 pairs of corresponding parts. Then we learned 2, I think our book calls them postulates, but they're theorems actually, that cut the work in half. Side, 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 and side, angle, side. Side, side, side says that 2 triangles are congruent if all 3 pairs of corresponding sides are congruent. Okay? So that's half as much work. That's just 3 pairs of congruent parts. And then side, angle, side says if you have 2 pairs of congruent sides and the included angles are congruent, and included basically means between, then those 2 triangles are congruent. So again, that's half as much work. That's just 3 pairs of congruent parts instead of the definition, which is 6. So on 24, let's see if what we can get to work out here. So we're given that segment, and remember what you need to do. You need to write down your given, write down what you're supposed to prove, draw the figure. There's a lot of writing on a proof. There's just no way around it. There just is. Okay? So we're given that segment YX is congruent to segment WZ. We're also given that segment YX is parallel to segment ZW, and we have to prove that triangle YXZ, the one in the upper right corner of the figure, is congruent to triangle WZX, the one in the lower left of the figure. So you write the given, you write what you're supposed to prove, you draw your figure, and let's go ahead and label what we're given onto our figure. And they did label part of it, but not everything. Segment YX, oh, now I've got to reorient the thing. So let's label that segment YX right there is congruent to segment WZ right there. Now what they didn't label for us is that segment YX here is parallel to segment ZW here. So those 2 segments are congruent to each other and they're parallel to each other. All right, well that's probably helpful. Now before we start our proof, let's try to figure out where we're going to go. Sometimes you can't. If a proof is complicated enough, you kind of struggle with what am I going to do to get to the, I know where I need to end up, but sometimes it's hard to figure out what to do to get there. But we try to make a plan. A plan's better than no plan. Okay? Well, let's see. If I have parallel sides or parallel lines and a transversal, I get congruent angle pairs, don't I? One of those angle pairs would be this angle and this angle because they're alternate interior angles, right? So I've got a pair of sides, now I've got a pair of congruent angles, and then notice how segment XZ is in both of our triangles? Well, it's congruent to itself, isn't it? So I can do side, angle, side, right? I'll have side, angle, side, congruent to side, angle, side. So I've got a plan. All right, so I've got that labeled, and let's start our proof. Statements, reasons. Statement 1, let's put the given in here. Segment YX is congruent to segment WZ. Segment YX is parallel to segment ZW. The reason both of those things are true is given. So if you can recall also, you can put A statement can have multiple parts as long as all of those multiple parts have the same reason. Okay? So the reason for both of those is given, so I can put it all into one statement. All right, now, statement 2. I think I want to say that this angle, which I can call angle YXZ, is congruent to this angle, which I'll call WZX. And what's my reason for that? Exactly. Alternate interior angles theorem. Okay. I also need to say that that segment's congruent to itself, don't it? So statement 3, segment XZ is congruent to segment XZ. Now this one's a property. Which property tells me that that segment is congruent to itself? Reflexive. And that's enough information, isn't it? That proves that those two triangles are congruent. So, triangle YXZ is congruent to triangle WZX. And what's my reason for that? Side angle side. So that's all I have to put, SAS. And as we wrap this up, remember the things you can use as reasons. You can use given information, definitions, postulates, theorems, and properties. And those are the only things you can use. Okay? We used given, we used a theorem, we used two theorems, and we used a property. So you don't necessarily use all of them in one proof, but those are the only things you're allowed to use as reasons. All right. Questions?